Hello and welcome to another video with me, Alex. This week we are going to be looking at the binomial expansion. It's going to tie in to the Edexcel module C2, and this will be chapter 5. So if you're watching along, this is chapter 5 of C2. And as I said, we're going to look at this thing called the binomial expansion, which is hugely important in physics and in maths in general and chemistry. It's used all the time, so if you want to go into one of those disciplines, make sure you know this well, and it will put you in good stead for university and further. So let's jump in. First, I want to just look at the question of what is a binomial. Okay, because you may be wondering, what is a binomial? Well, it's anything with two terms joined by plus/minus. Okay, that's the simple way of defining a polynomial. For example, 1 plus x, or 30 minus 2y, or 2z add v. Anything where you've got two terms and it's joined by plus or minus, that's binomial. Okay. What is binomial theory then? Well, binomial theory is basically just a quicker way of expanding binomial expressions such as two plus 3x to the power of 4. It's a quicker way of doing that. Obviously you could multiply out the brackets and you would get to the same answer, but it's going to take a lot longer than if you used the binomial expansion or binomial theory. So when it comes to C2, there's a few things that we need to do. The first of which is using Pascal's triangle to expand binomial expressions. That's the first thing that we're going to be doing. Okay, so I want us to consider the following. Let's consider a plus b to the power of 0, which is going to be equal to 1. And then a plus b to the power of 1. Going to be to a plus b. Now let's look at a plus b squared. So obviously these are all binomial expressions, okay? And we're going to expand them. If you expand this one, you'll get a squared plus 2ab plus b squared. Let's look at a couple more. A plus b cubed, which would be a cubed plus 3a squared b plus 3ab squared plus b cubed. And let's look at one more. If we expanded this one, we would get a to the 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4. Okay, what I'm going to do next is I'm going to take all of the coefficients of the terms. So the coefficient is just 1. We've got a 1 here, 1 here, 1 here, 2 here, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And I'm going to write them out in what is called Pascal's triangle. Okay, Pascal's triangle is a sequence of numbers, and it is formed by adding together the two numbers above the position you're at. So what do I mean by that? Where does this 2 come from? Well, if we look at the two numbers above, we've got a 1 there, and we've got a 1 there. 1 add 1 gives you 2. Let's look at this 3. 1 add 2 gives you 3. What about this one? 3 plus 3 gives you 6. So on and so on. So you can keep expanding this triangle and it goes on forever. So you can just keep going. This is Pascal's triangle, okay? And Pascal's triangle can be used to expand any of these polynomials. So, for example, if we wanted to expand 3x plus 7y to the power of 3, okay? What do we need to do? Well, we need to find the coefficients, and we do that by looking at Pascal's triangle, okay? And what we need to do is we need to find the correct row of Pascal's triangle. So we've got to the power of 3, which is actually going to mean it's going to be the 4th row. If that is confusing for you, there's a really simple way of getting this right. The power will always be the second coefficient, or it'll always be the second number in the row. So if it was to the power of 1, the second number in this one, right, power 3, the second number needs to be, the row needs to be the row with the second number 3. So has this got second number 3? No, no, no. Right, this row here, the second number is 3. This is our row. Okay, so the coefficients of our expansion will be 1, 3, 3, and 1. Okay? Now it's really simple to then write out what this will be once we've expanded it, okay? Because all we need to do is we write these coefficients, so it'll be a 1 here, times, okay? Now this is the bit that you just have to know how to do, just like pay attention. So you take the first term and you raise it to the full power to start with. 3x cubed, and then the second term will be raised to the power of 0. Okay, you'll see why I've written it in like this, because obviously 7y to the power of 0 is just 1, so technically we don't need it, but you'll see why in a minute. Okay, that's the first term. Now we add the second term, which has a coefficient of 3. It's multiplied by, right now this time it's 3x, and the powers on the 3x will decrease by 1, and the powers on the 7y will increase by 1. Okay, here's the check. The powers, the indices, should always add up to give you 3, or whatever your power is to begin with. In this case it's 3. So 3 plus 0, that's 3. 2 plus 1, that's 3. Right, next term, coefficient's 3. This time it's 3x to the power of 1 times 7y squared. And we've got one last term. It's got a coefficient of 1. It will be 3x to the 0 times 7y cubed. Sorry, that's difficult to see. So if we then simplify them, we would end up, and you can check this for yourselves, you'd end up with 27x cubed. Add 189 x squared y, add 441 xy squared, add 343 y cubed. And that's the expansion, which, as you can see, once you get quick at, would be much, much faster than multiplying out the 3 brackets. Okay? Brilliant. Right. That's the first thing that we need to be able to do. And as you do lots of those sort of questions, you'll be able to use Pascal's triangle really quickly. However, as the powers get quite high, Pascal's triangle becomes really inefficient. And that's when we need to make use of combinations and factorials notation. Okay. Right. what are we talking about here? Firstly, let's define what a factorial is. So a factorial is defined as n factorial, so some number would be equal to n times n minus 1 times n minus 2 times n minus 3 times ... 3 times 2 times 1. Okay, so you just keep taking off a number and multiplying it until you get to 1. Okay, and we must note very importantly that by definition, so there is a way that you can make sense of this, but simply put, by definition, 0 factorial is equal to 1. Okay, it's very important. So that's what a factorial is. Well, what does a factorial do? Let's look at an example to see what a factorial does. Let's imagine, so let's say if we had 3 colour balls in a bag. We've got a red one, we've got a yellow one, and we've got a green one. Okay, let's say that we wanted to pick all 3 bags out and then note down the order in which we pulled them out. Okay, let's write down all the different combinations of orders that we could have red, yellow, green. We'd have red, green, yellow. We could have yellow, red, green, yellow, green, red, green, red, yellow, and green, yellow, red. Okay, which obviously in total is 6. Okay, wow, what else could we have said? We could have said that we started with 3 possible balls that we could have pulled out. As soon as we took one out, we had 2 possible balls left. Then as soon as we took the second one out, we only had 1 possible ball left. We do 3 times 2 times 1, we get 6, which is equal to 3 factorial. Okay, so the number of combinations that those 3 balls could take, is 3 factorial. So factorial tells us the number of combinations that we could take, that a certain set could take. So in this case, it was 3 colour balls, and there's 6 different combinations, which is 3 factorial. Okay, good. What if we wanted to take 2 balls and we wanted to note the colour of those balls, but it didn't matter which order they came out, okay? So we just want to note the colour of those 2 balls that we take out. Well, let's look at the possible combinations. We could have red and green. Why have I written an 8? Red and green, which, I'll just say this, is the same as green and red, okay? It doesn't matter what order they come out. So we could have red and green, we could have red and yellow, we could have green and yellow. Okay, those are the only possible combinations. So in total, we'd have 3. Okay, mathematically, we can write this like this. We can say this is the same as 3, and then I would say 3 choose 2. Okay, so we've got 3 balls and we want to choose 2 of them. Or the other mathematical notation is 3, 2, like this. Okay, in vertical brackets. And this is actually calculated by 3 factorial divided by 2 factorial, 1 factorial. Okay, why is this? This is because 3 factorial is the total number of combinations of the 3 balls, okay? Then we take one out and we get 2 factorial is the total combination of the second lot of balls and 1 factorial here. And because we want to choose 2 of them, we end up doing 3 factorial divided by 2 factorial, 1 factorial. I'm not going to go into detail on this. This is a statistics topic, which I will probably make a video on at some point. I'm not going to discuss in great detail where this comes from right now, but there is good reason. Okay, so generally, we can say if we want our items from a group of n, we can write n choose r, or n r in vertical brackets, which would be equal to n factorial over n minus r factorial, r factorial. Okay? Good. So, how does this, you might be wondering, help us in expanding a binomial expansion? Okay? Hopefully you'll see, if we look at the example of, let's look at a group of 3. Okay, so just like before, we're going to say that we have 3 items. Let's look at all the possible values. So let's look at 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. Right, well 3 choose 0, using our definition, would be equal to 3 factorial over 3 factorial 0 factorial, which is 6 over 6 times 1, which is 1. Okay, I'll now just give you the result for the rest of them. This 3 choose 1 would be 3, 3 choose 2, as we saw before, would be 3, and 3 choose 3 would be 1. So written out in order, we have 1, 3, 3, 1, which, if you remember before, was the Pascal's triangle line for when we would have a power of 3. Okay, so this is actually the mathematical way that you calculate Pascal's triangle originally. So that means that we can directly use n choose r for binomial coefficients. What does that look like? Well, let's look at A add B again to the power of n. It'll look like this. So we've now got our unknown coefficient that would be in fact the first number in that row for Pascal's triangle. And then we'd have it times a to the n times b to the 0. And we add on n choose 1, a to the n minus 1, b to the 1. So again, the powers of the first term will decrease, powers of the second term will increase by 1. Add n choose 2, a to the n minus 2, b squared. That goes all the way up to n choose n, a to the 0, b to the n. So that's how we can use these combinations as coefficients for our binomial expansion. I'm going to write out one other form, and it's the form that I'd like you to remember. And what I'm going to write it as is, I'm going to do the expansion for a plus bx to the n. Okay, and I'm now going to write it without the power of 0, and we're going to write it like this. We're going to say it's n choose 0, a to the n, add n choose 1, a to the n minus 1, bx, add n choose 2, a to the n minus 2, b squared x squared, add n choose 3, a to the n minus 3, b cubed x cubed, dot dot dot, n choose n, b to the n, x to the n. Okay, now you don't need to remember both of these. As I say, if you remember this form, this will be more useful for you because you will be often expanding something of the form a plus bx to the power of n. Okay, that will be something you'll be expanding on a regular basis, and it's something that we're going to expand right now. Okay, so I'm just going to give you a little bit more time to just look at that, make sure that's in your head. Okay, so the last part of this chapter is that we need to be able to expand 1 add x to the n, and then use it to expand a plus bx to the n. Okay, so 1 add, sorry, that n is in the wrong place. 1 add x all to the power of n. This 1 add x to the n is a special case, and you can then use it to expand anything of the form a add bx to the n. Let's look at the expansion for 1 add x to the power of n. What do we have? Well, we will have that n choose 0, 1 to the n. Add n choose 1, 1 to the n minus 1, x to the 1. Add n choose 2, 1 to the n minus 2, x squared, add dot dot dot. N, choose n, 1 to the 0, x to the n. Okay, right, using the definition of our combination of our n choose, we'll rewrite this. So anything choose 0 is always 1, okay? And 1 to the power of anything is always 1. So this ends up, the first time is 1, and then we get n factorial over n minus 1 factorial 1 factorial x, add n factorial over n minus 2 factorial 2 factorial x squared, add n factorial over n minus 3 factorial 3 factorial x cubed, add dot dot dot. Okay, how are we going to simplify this a bit? Well, note that n factorial can be written as n times n minus 1 factorial, or could be written as n minus 1, n minus 2, n minus 3 factorial, say. Okay, you could always, as long as you're still ending up with n times n minus 1 times n minus 2 times n minus 3, it doesn't matter which one you put the factorial on. Okay, and that's really useful because it means that we can rewrite 1 add x to the power of n as 1. And now, if you look at this term here, if we replace n factorial with n times n minus 1 factorial, the n minus 1 factorial on top can cancel with the n minus 1 factorial on the bottom, and you just end up with n over 1 factorial x. Okay, but actually 1 factorial is 1, so that can go away, and you just get left with nx. If you do a similar process on the rest of them, you end up with this, n times n minus 1 over 2 factorial x squared, add n minus 1, n minus 2 over 3 factorial x cubed, and I'll write one more in, n minus 1, n minus 2, n minus 3 over 4 factorial x to the 4, add dot dot dot. Hopefully you can see the pattern there. Okay, so you just end up with another bracket on top, and it's n minus the next number. Okay, good. That is the expansion for 1 plus x to the n. So there's only one thing left, which is that we need to be able to expand something like 4 minus x to the power of 4. Okay, and we can use the expansion of 1 add x to do this. How? Well, if I rewrite this in a slightly strange way, I'm going to put these big brackets in. First seems arbitrary, but what I'm now going to do is I'm going to take a factor of 4 out of this bracket. So I'm going to say that's 4, 1 minus x over 4, all to the power of 4, which would be 4 to the power of 4, 1 minus x over 4 to the power of 4. And then if I rewrite this as 4 to the power of 4, 1 add bracket minus x over 4 to the power of 4. Now we can see that we can use the expansion for 1 add x, and all we have to do is use the exact same expansion, but every time we would have written x, we now have minus x over 4. Okay, which will look like this. 4 to the power of 4, bracket, 1, add, n is now 4, so it'll be 4 lots of minus x over 4, add 4 times 4 minus 1 over 2 factorial minus x over 4 squared, and you can keep going, you get the point. Okay, so that's how we expand something that's not quite yet of the form 1 add x to the n. All we have to do is take out this factor here, so we just take out this, in this case 4 to the power of 4, and you take that out of the fraction. You take that out of the bracket, sorry. That is everything for chapter 5 of C2. I hope this has been helpful. Please post any questions or comments in the comments section, and I'll try and get back to you. Until next time, it's been Alex. Thank you for watching.